Today we will see chapter number 2, amplitude modulations. I already gave you the slides, so you can go through. So we will be covering this in three parts. So today we will be covering first part. So before we start, I just want to let you all know that there will be a few formulas involved and some calculation involved in this chapter. So make sure you follow all the three parts for you to get a good understanding. Okay, so amplitude modulation. So modulation I already explained before this. So when you want to send some message as a signal, so you cannot send it over a long distance because the normal signal that we have is low frequency. So we need to attach that together with another high frequency signal, which we call as a carrier signal, so that it can be sent towards a certain distance. Okay, so the types of modulations, modulation method classification, there are various types of modulations. Okay, so modulations that we usually will see will be the analog modulation because it's already available for many years. So since the time of radio, the broadcasting. So mostly it's using the analog modulations. So under the analog modulation, there are few other modulations as well. And in this chapter, we will be seeing the amplitude modulation (AM), and in chapter 3 we will be seeing frequency modulation. So the other types of modulation will not be covered in this course. Okay, but you always can go to the internet to get more information about the other types of modulations. So we have digital modulations using a single or multi carrier modulations. So it is mostly related to satellites, and also the other types of digital systems. So we have pulse modulations, and we also have spread spectrum modulations. So these are some of the modulation method that we can see. Okay, so we will be covering this to the analog modulation, particularly AM and also FM. Okay, so why we need modulation? Yes, I already gave some intro in chapter 1. So modulation is a very important method that we will be using to send signals. Okay, so a message signal is whatever things that we want to convey. So that is what we call as a message signal. So it is a low frequency. So we need to get it transmitted over a distance. So if you can see today, so we are using WhatsApp call. So we can call to different continents. So we can call to UK, we can call to US, which is thousands of kilometers away. So we want the message to be conveyed over a distance. For it to establish a reliable communication. So reliable communication meaning, so what if you are sending A, so the receiver must receive A. So that is what we call as a reliable communication. So we cannot like we send A and the receiver receives Z. So that is not a reliable communication. So we want to establish communication. One of the important reason for communication is to establish a reliable communication. So in order to establish a reliable communication, you need to take help of a high frequency signal, which should not affect the original characteristic of the message signal. So meaning, so in order for you to pass your message signal, which is a low frequency signal, so we need to attach it together with the high frequency signal, which can travel a long distance. And the high frequency signal so must not affect the original characteristic. So we do want you are trying to send A. So A you attach with another carrier signal we call as a maybe a D. So you attach together. So it will go as AD, okay, towards the receiver. So we don't want it to affect the original characteristic meaning. So once you reach the place, so D will be demodulated, it will be removed. So A we shouldn't modify to become B. So that is what we are referring here. So the characteristic of the message signal, if changed, the message contained in it also alters. Yes, as I say, so if there are changes in the characteristic of the message signal, so meaning when it is delivered is not similar like original signal, so it means that the message is already altered. Okay, that means the communication is not successful. Okay, so high frequency signal, so we call it as a carrier signal. The carrier means is something that transport. Okay, so in bahasa Melayu we call it as a pembawa. Okay, carrier. Okay, can travel up to a long distance without getting affected by external disturbance. So when you are traveling towards a far distance, so if you are using wire, so wire will have a resistance inside which can influence or change the signal. So at the same time, if we are using wireless, there can be loss of information, can have interference. So a lot of external disturbance can affect. So high frequency signal, which is the carrier signal, so it can travel long distance, so without getting affected. So that's why high frequency signal is very important. So the process of you attaching your message signal with the carrier signal, we call it as a modulation. Okay, so modulation is a process of changing the parameter of the carrier signal in accordance with the instantaneous values of the modulating signal. So meaning, so if you see the carrier signal, so it will be the same pattern, but once it attached with the message signal, so it will follow the shape of the message signal. So that's why when we are demodulating at the end, so it's easier for us to separate both. Okay, so we will see this later. Okay, so the need of modulations. Okay, so reduction in the height of the antenna. So when we are transmitting something, so we will be transmitting from a from transmitter to the receiver. Okay, from the sending antenna to the receiving antenna. So when you have modulation, so you don't need to have a very long or very tall antenna, so we can reduce the size of the antenna. It is one of the need. Okay, then we avoid the mixing of signals. Okay, so we don't need to mix with the other signals, and that can have interference. We want to avoid that, so it can be avoided using the modulation method. So we make the multiplexing possible. So multiplexing is like this. So you have a signal 1, signal 2, signal 3. So you multiplex, then you send towards the channel, then you can have a multiplexer at the end, and it will become 1, 2, and 3 again. So we can, this method is possible using the modulations. Okay, so and also we want to increase the range of communication. So as I said earlier, so when you are not modulating, so you cannot travel too long because it's a low frequency. After some time, so it can have a distortion. So when you're modulating, so it can increase the range of communication. Especially you want to communicate thousands of kilometers or maybe 10,000s of kilometers. Okay, so it's very important method. Okay, so today we will see amplitude modulation. So what is amplitude modulation? Amplitude modulation is the process of changing the amplitude of the high frequency carrier signal with respect to the instantaneous value of the message signal. So you can see, so the message signal is like this. Okay, so you can see the shape. Okay, and this is a carrier signal. So carrier signal normally will be same for all. Okay, so let's say for example, so you want to travel from one place to another place using proton car. Okay, maybe proton saga. So proton saga, all the models will be the same. Okay, but the person who is commuting inside will be different. So that is same like a message signal, but the car, the size, the length, everything will be the same. So that is the carrier signal. So once you modulate, so you're mixing it together, So you can see what happened to the carrier signal. So this is actually the carrier signal, but it is following the shape of the modulated, okay, of the modulated signal. Okay, so it is following the message signals shape. Okay, so in between, so the will be the carrier signals. So we can control the amplitude. Okay, so if here is 0, so here will be 0. If here is 1, here will be 1. So it will follow the same size. Okay, so usually a carrier wave in analog modulation is sinusoidal. A sinusoidal meaning is like a sine wave. Okay, so this is a formula. Okay, a formula for a graph. Okay, so let's say since it's a modulation, we write it as a m over in a response to time equals to a is the amplitude. So amplitude is how tall is the wave. Okay, so amplitude, so cos, so omega c is the frequency. The frequency always related to time, and theta is the phase angle. Okay, so if there's a difference in phase, so you will have a uh, degree, okay, angle. Okay, so any of the three parameters can be varied in accordance to the baseband signal. Okay, so all these three, amplitude, frequency, and phase, can be uh, modified, can be varied according to your signal. Okay, so when you change, it will cause changes in the signal. Okay, so how to derive the AM modulation equation? So we will enter into some equations. Okay, so I just expect you to follow with me. Okay, so that you will understand, because I will explain step by step. And those who study with me last semester, I won't go a lot of information. I won't give a lot of information at one time, so that you can follow. Okay, so we will discuss a little bit, so that you can follow. Okay, so how to derive the AM modulation equation? Okay, let's say this is your information. Okay, so information, so it has a highest peak. Highest peak is EM. So let's say it's a highest peak. So the lowest peak is negative EM. Okay, so this is your carrier signal. So carrier signal, as I say, it will be the same. So the highest peak is EC. Okay, so it's traveling over time. So when you mix plus EM with EC, so then you will get a signal like this. Okay, so the highest point here. So let's say here 0, 0 plus here will be uh, maybe 1. Okay, that's why here is a bit like lesser than EM. So the maximum point here will be EM plus EC. So that's why this is the highest point. So when you combine all the points between the information signal and carrier signal, so after some time you will get this kind of images. So the top images will be mirrored to the down. So after some time, you will get the symmetrical design, asymmetrical design on both sides. Okay, that is what we call as a modulated signal. Okay, so the curve here on top, you can see is similar like this shape. Okay, and down is just a mirror of the same shape, and in between, so you just put the carrier signal. Okay, so that is how you draw AM modulation signal. Okay, so we will see some mathematical expression. Okay, okay, so I will go step by step. So you just follow me. Okay, so following are the mathematical expression of this wave. Okay, so time domain. Time domain meaning, so it's related to time. Okay, so over t, so we call it as a time domain. Okay, representation of the wave. So let the modulating signal. So modulating signal meaning the signal that you want to give. Okay, you want to pass message signal. So here in the book is written modulating signal. So meaning the signal, the message signal. Okay, so the message signal. So let's say we are saying so MT, so AM cos 2 pi fmt. So that so this is for the waveform, and the carrier signal is C for carrier. So CT equals to AC. AC means so amplitude of the carrier signal. So AM means amplitude of the modulating signal. Okay, cos 2 pi FC. So here you can see the frequency FM. So carrier signal frequency is FCT. Okay, so that's for the first thing. Okay, the equation of the amplitude modulated wave is so this is the signal that we want to send over a distance. So we write it as a ST. So you just like combine both. So you just plus both. Okay, so once you plus, so you'll get this equation one. So AC plus AM cos 2 pi FMT cos 2 pi FCT. So this is mathematics. So you try to write it down in a piece of paper and try to get this until you just combine these two until you get this equation. Okay, so we call it as the equation one. Okay, so this is the carrier signal. So this is your sorry, this is your message signal, and this is your carrier signal, and this is your modulated signal. Okay, so modulated signal. Okay, so modulation index. So there's a index called modulation index. So we'll see what is modulation index. So the modulation index, or the modulation depth of a modulation scheme, described by how much the modulated variable of the carrier signal varies around its unmodulated levels. It is defined differently in each modulation scheme. Instead, the level of modulation that the carrier wave undergoes. Okay, so modulation depth or modulation index is actually, if we put it in a simple word, so how much the modulation affect the carrier signal. Okay, so that is what it means. Let's say we rearrange equation one. So the equation in page 8 earlier. So this is the equation one. So let's say you rearrange. Okay, so you factorize a. Okay, so you factorize a. So you take out a. So it will become, so 1 plus am over ac. Okay, cos 2 pi fm t cos 2 pi fct. Okay, so you just like factorize this. Okay, so you can get this equation. This equation is actually the same. Just this am over ac you replace with mu. Okay, so mu is what we call as a modulation index. So modulation index, so mu is am over ac. Okay, amplitude of the modulating signal or the message signal divided by amplitude of the carrier signal. So we will get the modulation index. So let's say in the questions, so let's say I give, so calculate the modulation index. So you can straight away use this equation 3. So this is equation 3. So you no need to derive everything. So you can straight away, so if both values are given, so you can find the modulation index. Okay, so we'll see some questions later for you to try. Okay, so you can read this. I am not going to read, so I just straight away go to equation 4. Okay, so let's say you want to find the maximum amplitude of the modulated signal. Okay, so A max equals to AC plus AM. Okay, AC plus AM. So in the other way, so if you want to find the minimum amplitude of the modulated wave, so that is A min. So yeah, amplitude minimum equals to AC minus AM. Okay, so AC will always be the bigger than AM. Okay, so you combine equation 4 and equation 5. Let's say this is equation 5. Equation 4 plus with equation 5. So you can get A max plus A min equals to AC plus AM. Okay, here plus AC minus AM. Okay, so you solve this. So AC plus AC, so become 2AC. AM minus AM becomes 0. So at the end, you get 2AC. Okay, so 2AC. So let's say you want to find what is AC, so or amplitude of the carrier signal. So you rearrange this, so it will become A max plus A min over 2. Okay, so that will become the equation number 6. Okay, so far can follow?
Can sir.
Okay.
Yes, sir.
Okay, it's just a simple mathematics. So if you cannot understand, so you try to replace this with a value. Then you can understand better. Okay, so I continue. So let's say we want to find a subtraction between equation 5 and also equation 4. So A max minus A min. Okay, so A max is AC plus AM. So minus A min is AC minus AM. Okay, so here you can solve it. So after you solve, so A max minus A min is 2 AM. Okay, so AM. So AM is modulating signals amplitude. Okay, so similarly, you try to find AM. So AM is A max minus A min divided by 2. So we just bring this down. Okay, so we call it as a equation 7. Okay, so later in the calculation, so let's say I'm giving a question, so you no need to derive all this, so you straight away can use all this information. Even in the exam, I will include this in the appendix, so you no need to memorize. Okay, the ratio of equation 7 and equation 6. Ratio means equation 7 divided by equation 6. Okay, so this is equation 7. So equation 6 in the previous slide. Okay, so you can get, so AM over AC. AM over AC is, so equation 7, A max minus A min over 2. So AC, so we already calculated in the previous slide. Okay, so you can get A max plus A min over 2. Okay, so once you solve this, so we know from equation 3 mu equals to AM over AC. So here, so we replace this with mu. So mu is, so after you solve this, so you get A max minus A min over A max plus A min. So this is what we call it as a equation 8. Okay, so these are some of the derivation for a few equations that we will be using in the calculation. Okay, so therefore equation 3 and equation 8 are the two formulas for modulation index. Okay, so earlier, so this is one formula for modulation index, and one more formula is this. So both this, so depending on the information given in the question, so you can choose whether you want to use this equation, equation 3, or equation 8. Okay, so both are formula for modulation index calculation. So the modulation index or modulation depth is often denoted in percentage. Okay, so the same modulation. Okay, uh, so you can get a value. Okay, value, or you can get in the percentage. The percentage is what we call as a percentage of modulation. So you can see here. So let's say mu max. So mu max equals to 1. Okay, so if you find the ratio, it will become 1, or you times it 100. Okay, so whatever value you get for mu modulation index, you times with 100, you can calculate it as a percentage of modulation. So maximum is 1, so then you times with 100, so you become 100% of percentage of modulation. So so depends on the question. So if the questions ask you based on the ratio, then you can give the value between 0 to 1. So if the question asks calculate the percentage of modulation, so the same thing you just times with 100, convert it into percentage. Okay, so will get the percentage from modulation just by multiplying the modulation index value with 100. For perfect modulation, the value will be 1. Okay, so u max is 1, which implies the percentage of the modulation should be 100. Okay, so as I say, so the least will be, so u max equals to 0. Okay, so 0. Okay, so which will become a 0 percentage. Okay, so for instance, if the value is less than 1, so let's say the modulation index, so u mu equals to 0.5, then the modulated output will look like in the figure. So this can be the least, or it can be here. Okay, so we call it as a under modulated wave. Okay, so meaning, so the modulation index is less than 1, so it between 0 to 1. So if the value is like that, so we call it as a under modulated wave. So the waveform will be like this. Okay, so in between we'll have carrier wave. Okay, so the waveform will be nice. So just nice, similar like the carrier message. Okay, so there can be an instant where over modulated wave can be formed. So this happen because the modulation index is greater than 1. So let's say it's 1.5. Then you will have a over modulated wave. Okay, meaning there will be something like this. So the wave is actually like this. So it goes down and goes like this. But you can see it's overlapping. It's overlapping with each other. Okay. So as the value of modulation index increases, the carrier experience a 180-degree phase reversal. So it's happening a phase reversal here. Okay. So the signal is supposed to be down, but it's going up. So there can be a phase 180 degrees phase reversal, which cause additional sideband, and hence the wave get distorted. Okay, so once it become like this, the signal become like this, will become distorted, and it cannot be eliminated at the demodulation stage at the end of the signal. So you cannot extract the message properly, so it will become an error. So like how I say, so you are sending a message A, so the person might get a D, E, or F, so which will affect the communication. Okay, so you imagine you are trying to talk to your parents over a phone. You are saying A, they are listening as D. Uh, so it will create a lot of confusions and also problems. So we as engineers, we need to we need to eliminate this kind of problem over modulated wave. Okay, so far can follow. Okay,
Okay, sir.
okay. So I try to go as slow as possible. So we will see a few more slides, then we will conclude for today. Yes, I'm not going a lot. Okay, so then we go to another term. We call it as a bandwidth. Okay, I think you as a engineering student, you always encounter this word bandwidth, especially when you are using Wi-Fi in the house. So we always see they are mentioning bandwidth. So what is actually bandwidth? So even the AM, so amplitude modulated wave, as a bandwidth. Okay, so bandwidth, or we write it as a BW. Okay, BW, so not butterword. Okay, so BW is bandwidth. The bandwidth is a difference between the highest and lowest frequency of a signal. Okay, so bandwidth, maximum frequency f max minus f min, minimum frequency. So that is what we call it as a bandwidth. Okay, so mathematically we can write it like this. Okay, so consider the following equation of amplitude modulated wave. So earlier we have this amplitude modulation signal. So this is equation 2. So from the previous slide, so st equals to ac 1 plus mu cos 2 pi fm t cos 2 pi fct. Okay, so if you're not sure what is this, so refer back to the previous slide. Okay, so once you defactorize this, so you will get this equation. So meaning you try to times everything. Okay, AC times with 1 times with cos 2 pi fct. So you will get this. Okay, so you just defactorize, so meaning you expand it. So after expansion you will get this. Then to change it, okay, since this is combined, okay, AC mu cos 2 pi fct cos 2 pi fmt, you expand it using a trigonometric expansion, so you'll get this kind of equation. So don't worry, in the exam you no need to derive all this, so this is just for your information. Okay, so this is a trigonometric expansion, if you still remember your mathematics. Okay, so you can expand it to this form. Okay, so this will be the same here. So only this part, because it's having two cos, um, so we expand it to separate components. Okay, so once you will expand to this form, so the amplitude, you can see the amplitude modulated wave has three frequencies. So you have here fc, then you have fc plus fm, then you have fc minus fm. Okay, so fc is carrier frequency, okay, the frequency of the carrier wave. So then you have a fc plus fm, we call it as a upper sideband frequency. So we, that is fc plus fm. So fc plus fm is actually f max. Okay, so here you can see f max. So f max is actually fc plus fm. And lower sideband frequency, or we call it as a f min, minimum frequency, is fc minus fm. Okay, so now we try to replace these values inside this equation. So we will get this. Okay, f max is fc plus fm, fc plus fm, minus f min is fc minus fm. Okay, so you solve it, so you will get bandwidth equals to 2 times of modulating frequency. Okay, so modulated waves frequency. Okay, so you can see I show you in the graph. So this is your carrier frequency, carrier frequency in the middle. Is so here you have a lower sideband, so which is fc minus fm, and this side you have a upper sideband fc plus fm. So in between these two, that is what we call it as a bandwidth. Okay. Okay, so in the questions, so the question can ask you to calculate the bandwidth. So you can use this formula or this formula to calculate, or you can derive it from this formula, depends on the information. Okay, and the questions also can ask you to calculate power of the amplitude modulation wave. Okay, so we are taking this from the equation from the previous slide, from page number 14. Okay, so power of amplitude modulated wave is equal to the sum of powers of carrier, upper sideband and lower sideband frequency component. Okay, so we can see we have three components: component 1, component 2, and component 3. Okay, so this is your carrier signal. So this is your upper sideband, and this is your lower sideband. So you need to combine the powers of all three. Okay, so P total. So P total means power total equals to PC. PC is carrier wave power. So P USB. So not the USB we are using. Upper sideband. Power of upper sideband plus with power of lower sideband. Okay, so you combine these three things, three elements, you can calculate the power in total. Okay, so the question can ask you to calculate the power. Okay, so we know the power of a waveform cos signal, P equals to vrms square over r. Okay, so equals to, so this is also equals to vm. Okay, so over square root of 2 over 2. So this, the top part, your square root. Okay, so vrms is rms value of cos signal. Okay, and vm is the peak value of the signal. So, cos signal means the signal that you are trying to transmit. Okay. Okay, don't worry about the formulas. Later we will see the examples. Yeah, I also will do the tutorial on this chapter. Okay, so let's say you want to calculate the carrier power. So PC is, so you replace in the previous formula. So AC over square root of 2 square divided by R. So you will get the carrier power as AC square over 2R. So upper sideband, so PUSB equals to AC mu, okay, over 2 square root of 2 square over R. So you will get AC square mu square over 8R, and lower sideband is AC square mu square over 8R. So you can see both are the same. Okay, so both upper sideband power and also lower sideband power are the same. Okay, so let's say you want to calculate the power for all the three components. So you want to calculate the PT equals to, so this already shown earlier. So all three you combine. So you at the end you will get this. Okay, after you factorize, so you can get this and you can convert it into this formula. Okay, so I know there are a lot of steps. So later you just go through again and try to understand how the formulas are derived. So normally we will just use the formulas given in the box, okay, box or the important formula. And as I say, it will be given in the appendix as well for your calculation. Okay, so we can use the above formula to calculate the power of amplitude modulated wave when the carrier power and the modulation index are known. Okay, so if the modulation index is mu equals to 1, and the power of AM wave is equals to 1.5 times the carrier power. So meaning, so if mu equals to 1, so you just replace this here. So what will happen if mu become 1? So you have PC 1 mu 1 square is 1 over 2. So 1 plus 1 over 2, so become 1.5. So 1.5. So you will get PT equals to 1.5 PC. So that is what it is saying here. So the power of amplitude modulated wave is equals to 1.5 times the carrier power. Okay, so PT equals to 1 point times of carrier power. Okay, so the power required for transmitting the AM wave is 1.5 times the carrier power for the perfect modulation. Okay, so if you want to achieve a perfect modulation, so you need to supply power 1.5 times of the carrier power PC. Then you will get a perfect modulation, so without any distortion. So that is how we will calculate. Okay, so I give you two questions. Okay, so you try first. Okay, so try it yourself one. Okay, so the modulating signal 20 cos 2 pi times 10 to the power of 3 t is used to calculate a carrier signal 40 cos 2 pi times 10 to the power of 4 t. Find the modulation index. So like how we see earlier, mu, so modulation index, percentage of modulation, frequencies of sideband components. So meaning sideband components, we have upper sideband and lower sideband, and you need to find the amplitudes and you need to find the bandwidth. Okay, so everything that we studied today. So try to complete this question. Okay, for you to get a better understanding. Okay, of whatever, because there are a lot of formulas involved. When you do the question, then you will understand it better. Okay, so this is your first question. So it's available in your lecture note as well. So do this before tomorrow's class. Okay, so tomorrow's class, you try to compare with whatever I'm giving. Okay. If we cannot discuss tomorrow, we will discuss during the tutorial. So please complete first. Okay. So this is your first question, and this is your second question. Okay. So modulating signal. So empty. So if you return empty, meaning it's a modulating signal. So 10 cos 2 pi times 10 to the power of 3t is an amplitude modulated with a carrier signal. So carrier signal is Ct. So equals to 50 cos 2 pi times 10 to the power of 5t. So you need to find the modulation index, the carrier power. Okay, so carrier powers Pc, and the power required for transmitting AM wave. So P total. Okay, so you need to find. Okay, so try to answer these two questions for you to get a better understanding. Okay, so any questions so far?
Sir,
Yes.
yeah, it says 10 cos 2 pi times 10 to the power 3t.
Yeah.
Is 10 to the power 3t the frequency?
Yeah, you need to find it out. So
Oh,
when you try to find out, you compare with the standard formula, then you will know which is frequency, so which is amplitude. So if you never try, so when I explain, you cannot compare. So when you do yourself and you make mistake, then you learn. It will give a better understanding for you. So it's okay. I will give the answer later. Okay. So you do first. So try it yourself first. Okay. So any other questions? No questions.
No, sir.
Okay. So if no questions, we will finish with this. So I will take attendance. So please wait.